Hi there, this is exercise 1B.1 I've called it. Now look, this is very, very similar to a video I've already done and posted on the statistics unit. So if you're doing statistics and you're doing the discrete module for A Level Further Maths on the OCR, then this is broadly the same in both of them. But I've done it here just to make sure it's just sort of highlighted in everyone's minds that they actually do it if they are doing the discrete unit. So anyway, I'm going to do this. So just bear that in mind. This is all about counting and repetitions, and we get a lot of this kind of stuff on the discrete exam. So let's have a go at it. Now the first question is based on that thing I put up there just now, the kids menu. You're allowed to go in and all the different varieties from the menu, and it looks like you've got to have some protein, you've got to have a fruit, you've got to have a veg, you've got to have a side, and you've got to have a drink. So let's just do this. So look, I've done it. It says choose one fruit and one veg, so I'm just kind of, that's a fruit. Watermelon's a fruit, whereas the carrots is obviously veg, and cucumber I'm going to say is a veg as well. So I'm going to choose this. Basically I've got to have one of each because it says one fruit and one veg. Now look, this is going to use something called the product rule for counting, and I'll show you that properly in a bit, but broadly speaking what I do is say I've got to have a protein. Well, there's four options. I've got to have a fruit, and as I've seen there's two fruits here, so I times by 2. Now this actually never used to come up on GCSE, but more recently it does quite a lot. So I imagine all of you doing this thinking this is dead easy. I can do this. Oh, excellent. Because it is quite easy, I think. Then you've got to choose a side. How many of those? There's 4 different sides down there. And you've got to choose a drink, and there seems to be 3 different options for that as well. So 4 times 2 times 2 times 4 times 3. Yeah, I got that. And I reckon that's 192 different versions of those meals that people can have. 192 choices, yes. So bear that in mind, that that is just the product rule for counting, and I've got effectively 2 of such rules, and this is the product rule that I was just referred to. The product principle is if you want the number of things that can happen when out of A and B happening, and the important word there is the and in the middle, then you times the number of things that can happen in an A times by the number of things that can happen in B. That's basically what we did, wasn't it? But you've also got this addition principle, which says if you want to find the number of things, or the probabilities ultimately of things that can happen with A or B happening. Now, again, critically, it's now an or. It's the same as a probability. And when we did tree diagrams, if it was an or and stuff like that, you ended up adding. And so you get this add rule, the addition principle. And it assumes that both events are mutually exclusive. This, I suppose, assumes both events are independent. But you get this idea that they probably will be when you get asked to do these and these questions. And the exam has 10 questions in section A and 4 questions in section B. Okay, so we've got section A, and there are 10 there. And then we've got section B, and there are, what did it say, 4? So part A says you've got to choose, you've calculated how many different ways there are to choose the questions if you must choose one question from each section. Now, if I've got to choose 10 from the first, so this is part A now, if I've got to do 10 from the first, and this is the critical way, because it's one from each, you've got to do one from that and one from the other. So I've also got 4 choices in the second one. The product rule for counting, 10 times 4 is 40. That was easy enough, and it should be easy. One question from either section. Oh, right. Now, from either section. So basically, I don't care where it comes from, but I just want one question from all of that. There's not from each, it's just from either. So now, effectively, I treat that as 14, I suppose. It's really 10 plus the 4. I've got 14 choices. I'm only choosing one from both of them. 14 and 40, yes. Now, I should also make sure you're aware of what this factorial notation is. It's always written with an exclamation mark. So, for instance, 3 factorial is, well, usually people write 3 times 2 times 1. It doesn't really matter what order you write them in, but 3 times 2 times 1 is 6. And you're meant to know factorial notation. And you've probably seen it already, but there it is, just to make sure that if you haven't, you need to do it. So the whole point about this, I suppose, is if I'm doing factorial notation here, it's 4 times 3 times 2 times 1, and that, well, it's obviously 4 times bigger than that. That's 24. 6 factorial. Notice where it's exclamation mark, and I'm calling it factorial. This is 6 times 5 times 4 times 3 times 2 times 1. Just count down all the way with the whole numbers until you get to the bottom, till you get to 1. And I think you get 720 there. Hopefully I haven't made the daft mistake. 5, I think that's right. And well, look, here's a weird one. And there is actually a button on your calculator. You probably already know where it is, but if you find the button that usually it says n factorial or x factorial, maybe it will say on your calculator. And if you find that button and you press 0 first and then press that button, it's rather surprising it comes up with the answer 1. This is 1. Why 0 factorial is equal to 1 surprised me when I was doing my A-level many moons ago, when I was at 17 or 18, whatever I was. So it is a surprise. I think mathematicians have just found it easier to call it 1 over the years. Justifying it is harder, I think. How many different ways are there of arranging 7 letters? Oh, I've got 7 letters. Okay, A, B, C, D, E, F, G. Well, this is just arrangements, I think. This is just 7 factorial. If you ever get a question like this, oh, you're arranging so many things and there's no constraints on it whatsoever, it's 7 factorial. Now, 7 factorial. Apparently it's 5040. Look at that. I had to check because I haven't got a calculator with me. Rather stupid. I should have brought one up with me. But anyway, 7 factorial is 5040, and you can do those straight from your calculator. 721 there. I've got them right. Okay, look, arranging letters in the word. This is surprisingly common in exam questions, and I've got some questions which will hopefully test you and make sure you know what you're doing. And look at spinach. Basically, I've got 1, 2, 3, 4, 5, 6. I've got 7 letters. So it's almost like what I was just doing just here. I was basically saying I've got these letters. I've got 7 of them. 7 factorial is 5040. So here it is also 7 letters, 7 factorial, 5040. Now you might be thinking, why is he doing this again? Because sometimes with real words you get letters repeated, and this is why this was called counting and repetitions. The repetitions are from the 2 R's that we have in the word carrot. So how do you deal with that? Well, first of all, you do it the same way. You've got 1, 2, 3, 4, 5, 6 letters. So I do 6 factorial. But because I've got 2 R's basically means I've got to divide it. And I divide by the fact I've got 2 of them, 2 factorial. And notice that is equal to 360. When I've typed it in anyway, it's equal to 360. Now, vegetables, I hope I've spelled it right. I've noticed in here, first of all, 2, 4, 6, 8. I think I may have 10 letters. So therefore 10 factorial. But of course, then we now know we've got to be careful with the repeated ones. What we got repeated? I've got 3 E's. So I've got to divide by 3 factorial. There we go. Oh, it went a bit funny on me there. I'll pretend that says factorial. Is there anything else which is... I don't think there's anything else repeated. So what is that? 10 factorial divided by 3 factorial apparently is 604. That's a lot of different words. You can make out the letters in vegetables. But apparently there's 604,800 words. Now, how many of those make proper words? I imagine it's quite limited. But... there you go. There's lots of different ways of arranging those letters. And this is all this is. It's like counting how many different ways of arranging letters in a word. Cabbage. What can you do with cabbage? Well, you've got C-A-B. Oh, I've got 2 A's and I've got 2 B's. And so how do I deal with that? Well, how many letters, first of all? 3. There's 7 letters. So I've got 7 factorial. I've got 2 A's, so I'm going to divide by 2 factorial. And I've got another 2 B's. So I divide by it again. Be a bit careful when you type it in. With the proper calculator buttons now, we've put the fractions in, so it's not so bad. But if you're using just the divide button, you might make mistakes if you're not careful. But anyway, when I typed it in, I got 1,260 different words you can make out of the word cabbage. Who knew? Asparagus. You can see straight away while I'm just holding back a bit. There's loads of letters repeated. How many letters in total? 3, 4, 5, 6, 7, 8, 9. 9 letters in total. There's lots of A's. 1, 2. There's 3 A's. And here's the trick with this. You do 3 factorial. And are there any S's? Yes, there are 2 S's, so I'm going to divide by 2 S's as well. P, no, there's just the 1P. A, R, I think that's it. Do I agree with that here? Yes, I do. 9 factorial over 3 factorial 2 factorial is 30240, 30,000 odd. Different ways of arranging the letters in the word asparagus. And look, here's 3 more. I've just made up 3 more for you to have a look at. You're welcome to pause the video and do it, or just let me do it for you. So here I've got 5 letters. They're all different. So this one's going to be 5 factorial. What's this one going to be? 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. And by the way, 5 factorial, I forgot to write, 120. 9 letters. Of those, what have I got? I've got 2 E's, definitely. Is there anything else there I need to look at? I don't think there is. So if you type this in, I wrote this down before because I haven't got a calculator. I'm just relying on my when I did this last time. 181,000 apparently. 9 factorial with 9 letters divided by the fact there's 2 E's. There we go. And statistically, they used to look at them. That is a classic word for this, isn't it? Because it basically is stats that we're doing here, even if it's on the discrete module. So what have we got? 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that 10 again? I'm going to count that again just to make sure. 4 up to there. 5, 6, 7, 8. I think it's 10. Now, what have I got repeating? I've got 3 S's, so I've got to divide by 3 factorial. I've got 3 T's. I've got to divide by another 3 factorial. I's, 2 I's. And I suspect that's it. And again, when I type this in, what did I get? 50,400, according to me anyway. Let's see if those 3 answers are right. Answers, 50,400. Yeah, I've got those right based on what I wrote last time anyway. So you can check those for me. Look, I quite like that. As I say, this is a carbon copy of a video I did with some stats students. I was one of the ones which has proven very useful for those stats students if I look at the statistics behind it. But I know it's also something that decision students do, and you might be doing mechanics, for instance, or further pure, in addition to the normal core pure. And if that's the case, you would have missed this. So that's why this is here. Now, there's going to be a few others within the discrete book that we were using in my last school. This all came up in exercise 1B, but you won't be able to do it all until I've gone through a few other videos as well. Or you might be able to just make it up yourself. But anyway, thank you very much. Good luck in your exams, and look out for the other videos.